we're just going to recap real quick. This is kind of like our warm-up. We're going to recap the other sections that we have already covered. So the first section we've covered is 5.2.1. Does anyone remember what 5.2.1 was? Factoring how? How are we? No, it wasn't A equals GCF. That's correct. It was factoring GCF. Okay? So this is kind of like the first thing we hit on. So the example for this is 10x squared minus 20x. Okay? 10x squared minus 20x. So this is kind of like our warm-up right now. So this is problems you should be practicing right now. Okay? You should be practicing this problem. Trying to do this. Factoring using the GCF. Greatest common factor. What do both of them have in common that we can factor out? What can we pull out of each other? Okay, that's what you're trying to do. So I hear the word 10, okay? And that's right, but I kind of need another piece of it. X, 10x. Notice they both have a 10 and an x to give away. So whenever I pull out that 10x, I got to think to myself, if I pull out a 10x, what am I left with inside here?
X.
Just an x, that's correct. All right. And then if I pull out a 10 from 20, what should I be left with? 2. And then x and x cancel out, so this is what I'm left with. Okay? That's mainly just a recap of factoring using the GCF right there. You can do this, you're doing okay. All right? So that was the first section we covered when we were talking about factoring. All right? The second section was 5.2.2. And that was factoring, somebody said it earlier, A equals 1. Factoring with A equals 1. A equals 1. So I'm going to give us an example for that. X squared plus 13x. I think I went with minus 30. So here's this example. So we're factoring when A is equal to 1. Real quick, try and see if you can do it. Notice it's a trinomial. It's got 3 terms. Okay? When we see that, x squared, x to the first, no x's. So it is in that standard form. I know I can factor it like so. Draw my 2 sets of parentheses. My x's go in the front. I was telling my classes this yesterday. Don't ever put 2 x's in the same parenthesis. Okay? It's the same for you guys. You don't ever want to have 2 x's in the same car. It doesn't work out well. So just think about it. Don't ever put 2 x's in the same parenthesis. Don't ever put 2 x's in the same car. Right? So now I've got x and x. I look at my 30 at the back end. And I say, what are my factors of 30? 1 and 30, 2 and 15, 3 and 10, 5 and 6. I'm looking at these, I'm like, how could I get positive 13?
2 and 15.
2 and 15. Well, 3 and 10 could also get it. But why doesn't 3 and 10 work? Does anybody know? Say that again?
You'll end up getting 7 because you'll have to subtract them.
Yeah. So since this is a minus sign, they have to be opposites. So it can't be 3 and 10. Because that doesn't give me 13 if one's positive and one's negative. So it has to be 2 and 15. Now how do I get positive 13?
Positive 15.
Positive 15. That's correct. X minus 2, x plus 15. Okay? We're done. A equals 1. You can do that, you're good to go. You got that section knocked down. Alright? There's one other section that we've covered so far. Okay? And it's actually 5.2.4. Okay? What we're doing today is 0.3. What we're doing today is 0.3. So this is 5.2.4. Anybody know what it is?
What I think.
Okay.
Is it the difference?
That's correct. Difference of 2 squares. Difference of 2 squares. That was that other section. That's the 3 sections we've covered so far. And then today we're going to hit that 4th one. Well, actually, point 3. So an example for that would be something like 16x squared minus 49. 16x squared minus 49. I want you to try and factor that. Remember, it's a difference of 2 squares. It only works when we have a difference, minus in the middle, and both of these numbers are squares, or perfect squares. Okay? Perfect squares. It means I can draw 2 parentheses, and I can say, what's the square root of this guy? 4x. What's the square root of this guy? 7. And then flip my signs. And I'm done. So, those 3 sections we've covered, you've mastered. We're moving on. We're about to start 5.2.3. Any questions about these 3? Okay. I'll give you a second to finish writing. Okay. So, today's kind of bulk discussion is going to be about 5.2.3. Okay? 5.2.3. And that is, I can factor a quadratic equation when A does not equal 1. When A does not equal 1. That means typically A is going to be greater than 1. An integer greater than 1. 2, 3, 4, 5, 6, 7, 12. I don't care what it is, but there's a way that we can factor it. Okay? So A does not equal 1. Alright, so the way we're just going to call this, okay, the easy way. Okay, we're just going to call it factoring the easy way. That's the easiest way for us to remember it. We're calling this factoring the easy way. Okay? Factoring the easy way. And the only way I can do this right now is just jumping in and showing you an example. Okay? So this first example is just going to jump right in. We're going to start doing this. 3x squared minus 2x. 3x squared minus 2x minus 5. Okay? So notice right now, before I said anytime we saw a number out in front, it was like red lights went off, flashing lights. We said, there's something wrong. Can we factor this? Before we couldn't, but now we can. We always want to check and see, is there a GCF? In this case, is there a GCF? No. 3, 2, and 5 have nothing in common. So we're going to use what we call the easy way of factoring. Okay? This is when A is greater than 1. So, very few steps, and it kind of all relates back to what we've already done. The first step, we're going to take this leading coefficient, okay, that 3 out in front, the leading coefficient, and we got to get rid of it so we can make math easier for us. By doing so, we're going to multiply it to the back end. So whenever I rewrite it, I'm going to be left with x squared minus 2x minus 15. We did some crazy math there. Okay, and that's okay. It's all going to work out. So step 1, we need to get rid of the leading coefficient, multiply it to the back end. Okay? So now step 2. Step 2 is I'm actually going to factor this guy. Factor this guy. X and x. Remember, I look at 15. And I say, what are my factors of 15? 1 and 15, 3 and 5. That's all we got. 1 and 15, 3 and 5. So now at step 2, I'm just straight up factoring. I noticed 3 and 5 will give me -2. So positive 3, -5. That doesn't matter which order it's in, remember that. It's okay for it to be in any order. X plus 3, x minus 5. Okay, step 3. This is a big step. We take whatever that leading coefficient was, that 3 out in front, and we're going to bring it down and divide it from each of these numbers. So that's going to be x plus 3 divided by 3. That's that leading coefficient I'm bringing down. X minus 5 divided by 3. See what I did there? I just brought down the leading coefficient and divided it at the end. Okay? So, here's a very big step, and we're going to write this very big. Simplify. I hope I spelled that right. Simplify. We have to look at these fractions and we have to simplify them. We got to see what they have in common and simplify. So, step 4 is finally simplify. Let's see where I'm at. What does 3 and 3 reduce to? 1. So I've got x plus 1. Can 5 and 3 reduce? No. 5 and 3 cannot reduce. It's just 5 over 3. So what we do, take the number that's on the bottom, once we've simplified, and bring it out in front. 3x minus 5. Check. I'm done. I have factored quadratic equation with a leading coefficient not equal to 1. Okay? The easy way of doing it. Okay? And you're kind of still looking at it like, you know, I kind of see it. Kind of see it. We need to do another example. Okay? Need to do another example. We okay? Moving on? All right. So, example 2. Example 2 looks like this guy. We've got 2x squared plus 3x minus 9. 2x squared plus 3x minus 9, and we got to factor this guy. Okay? So I look, I say, is there a GCF? 2, 3, and -9. No. They have nothing in common at all. So I use the easy way method when a is greater than 1. When a does not equal 1. What's the first step?
Take the leading coefficient and multiply it by 1.
That's right. So I'm left with x squared plus 3x minus 18. X squared plus 3x minus 18. That's the first step. What was my second step? Factor. X's. Remember, I take a look at 18. 1 and 18, 2 and 9, 3 and 6. And I say, how could I somehow get a positive 3? 6 and 3. X plus 6, x minus 3. So once I've factored it, I got to go on to step 3. Step 3. I take that leading coefficient up here and I drop it down and divide. So this time I've got x plus 6 divided by 2, x minus 3 divided by 2. Step 4 is the most important. It's where I simplify. Okay, it's where I simplify. Step 4 is simplify. So let's think about this. What's 6 divided by 2?
3.
3. So that gives me x plus 3. Can I reduce 3 and 2?
No.
No, so I take the 2,
Bring it to the front.
bring it to the front. 2x minus 3. Not too bad? We okay? Alright, now let's check this. Use the distributive property to check. 2x times x 2x squared. X times negative 3. 3 times 2 gives me 6x. And 3 times negative 3 gives me negative 9. Whenever I combine like terms, I get something like 2x squared plus 3x minus 9. Is that where I started with?
Yeah.
That is. Check. Did it right. Okay? I did it right. We're going to do one more example after this. We're doing okay so far? Example 3. We've got 4x squared minus 17x plus 4. Four x squared minus 17x plus 4. Okay? Step 1. Bring the 4 to the back. So x squared minus 17x plus 16. That's step 1.
Which one?
Yes, ma'am.
What would you do if they did have a GCF?
If they did have a GCF, I would factor that out first.
But it'd still be the same 4 steps, right?
If they all have a GCF of 4, that 4 would go away, and now I would just do a equals 1
Okay.
factor. Okay.
Yes, sir.
Step 2, factors such as a equals 1. I get x and x. What are my factors of 16 that add up or subtract to give me negative 17? 16 and 1. Negative 16, negative 1. Step 3 tells me I'm going to take that leading coefficient and divide. X minus 16 over 4, x minus 1 over 4. Do they reduce? X minus 4 and 4x minus 1. Remember, I take that bottom guy and bring it out front. 4x minus 1. Questions? Okay. Okay. Do I have a volunteer that would like to try one of these? Chastity, I saw that hand spike up right away. Okay. All right, I've got one for you. All right, example 4 is going to be on chastity. Example 4 says this. We've got 6x squared plus 5x minus 6. And we're going to factor this. We're going to use the easy way. Here you go. Now, guys, I need you to do this with her because this one might work out a little bit different, okay, towards the end. What factors are we going to use here? We got 36 and 1. We got 6 and 6. What else equals
4 and
36?
9.
4 and 9. Okay. Plus 9 minus 4, okay? So now she's dropping down that leading coefficient, dividing by 6. All right, just kind of stand back. Let's look at this, guys. This is the situation where we really have to focus. We have to reduce 9 over 6. We have to reduce 4 over 6. to its simplest form, okay? Three over 2 and 2 over 3. Okay, awesome. One issue. What happened right here? Something looks wrong on 2/3. That's right. Because remember, we take the bottom and bring it to the front. Take the bottom and bring it to the front. Okay, there it is. Awesome. You don't even have to worry about checking it right now. All right, so let's check it out. Chastity said 9 over 6, they both have a 3 in common. So 9 divided by 3 is 3, 6 divided by 3 is 2. So I've got x plus 3 over 2. I bring the front down to the front, or bring that bottom, that denominator down to the front. And then the same thing over here, we reduced it, brought the denominator out in front, and did it perfectly, okay? Any questions? All right, so this is the easy method. It's used whenever A does not equal 1. That's the only time. Section 5.2.3, when A does not equal 1, we're going to use the easy way by factoring. All right, awesome.